Have you ever wondered what might happen if the Earth suddenly stopped spinning? It may sound like a plot straight out of a science fiction novel, but it's a question that has puzzled scientists for centuries. To understand the implications of this, we first need to grasp the fundamental phenomenon of the Earth's rotation. Every single day, our planet performs a remarkable feat. It spins on its axis, an imaginary line running from the North Pole to the South Pole, completing a full rotation every 24 hours. This rotation isn't just a planetary pirouette, though, it's a vital part of life as we know it. You see, the Earth's rotation is the reason we experience the cycle of day and night. As the Earth spins, different parts of the world face the sun. When your part of the world is facing the sun, it's daytime for you. And when it's facing away, it's nighttime. This cycle has shaped our lives, our cultures, and even our biology in countless ways. It dictates when we sleep and when we wake, when we work and when we rest. But the rotation does more than just create day and night. It influences our climate, our weather, and even the shape of our planet. The Earth isn't a perfect sphere, it's an oblate spheroid, a shape that's slightly squashed at the poles and bulging at the equator. This shape is a direct result of the Earth's rotation. So the Earth's spin is a fundamental part of our world. It's woven into the fabric of our existence, from the rising and setting of the sun to the very shape of our planet. It's a silent, constant dance that has been performed for over 4.5 billion years. Now that we understand the basics of the Earth's rotation, let's explore the catastrophic consequences if it were to stop. Because if our planet's spin were to suddenly cease, the world as we know it would be turned upside down, quite literally, but more on that in the next scene. Imagine for a moment the Earth abruptly comes to a halt. What would happen? Well, the immediate effects would be catastrophic. You see, our planet's rotation isn't just a simple spin, it's an essential part of the delicate balance that makes life possible. The sudden stop would trigger a violent reaction, thanks to a principle known as the conservation of angular momentum. In a nutshell, angular momentum is the tendency of rotating objects to keep rotating. It's the reason a spinning top stays upright, and it's also why our planet keeps turning. If the Earth were to stop suddenly, this conserved momentum would have to go somewhere. And that somewhere would be the atmosphere and the oceans. So what does this mean? Well, imagine the fastest winds you can think of and then multiply that by 100. We're talking about winds that would reach a staggering 1,670 kilometers per hour. The entire atmosphere would be swept up in a global hurricane like nothing we've ever seen. And it wouldn't just be the winds. The oceans too would keep moving, creating colossal tsunamis that would sweep across continents. The seas would surge, crashing into cities and towns, causing unimaginable destruction. But the chaos wouldn't end there. You know when you're in a car, and it suddenly stops, and you lurch forward? That's inertia. And everything on Earth, from skyscrapers to elephants, would experience this. Anything not firmly attached to the crust of the Earth would be flung eastward at the same speed our planet was rotating. This initial chaos is just the beginning. The long-term effects are even more dramatic. So hold on to your hats, folks. We're about to dive into a world turned upside down. After the initial chaos subsides, how would the Earth's climate be affected? Now let's dive into this. Imagine a world divided into perpetual night on one side and eternal day on the other. This is what would happen if the Earth stopped spinning. Without the Earth's rotation to distribute sunlight and heat evenly, one half of the globe would be constantly exposed to the sun's rays, while the other half would be shrouded in darkness. On the sunlit side, temperatures would skyrocket, creating a scorching desert with unbearable heat. The relentless exposure to the sun's rays would cause the moisture in the soil and the oceans to evaporate, leading to a drastic increase in humidity. This could potentially result in a permanent thick cloud cover, blocking out the sun and creating a kind of nuclear winter scenario. On the flip side, the half of the Earth in perpetual darkness would become a frozen wasteland. Temperatures would plunge to levels far below what we experience in the coldest winters today. The lack of sunlight would cause all surface water to freeze, leading to a planet half covered in ice. And we can't forget about the atmosphere. Right now, Earth's rotation helps distribute the atmosphere evenly around the globe. But if the Earth stopped spinning, gravity would pull the majority of the air towards the poles, causing extreme atmospheric pressure in these regions. This pressure imbalance would create superstorms, with winds far more powerful than any hurricane we've experienced. The Earth's rotation also plays a key role in the water cycle, driving the movement of ocean currents and influencing weather patterns. Without it, The water cycle would be severely disrupted, leading to unpredictable and extreme weather events. The cessation of Earth's rotation would thus lead to a world of extreme temperature differences, atmospheric pressure imbalances, and disrupted weather patterns. It's safe to say that life as we know it would be drastically different, and survival would be a significant challenge. So a spinning Earth is crucial for our survival, but how does it manage to keep spinning? Why does the Earth keep spinning, and why won't it stop anytime soon? Well, the answer lies in the concept of angular momentum. But what exactly is that? In simple terms, angular momentum is a measure of the amount of rotation an object has. It's calculated by multiplying the mass of the object, its speed, and the distance from the axis of rotation. So how does this relate to our planet? Let's think of Earth as a giant spinning top. When it first formed over 4.5 billion years ago, it started spinning due to the conservation of angular momentum from the dust and gas that created it. And since there are no external forces in space to stop it, Earth has been spinning ever since. The principle of conservation of angular momentum tells us that the total angular momentum of a system remains constant unless acted upon by an external force. This is similar to Newton's first law of motion, which states that an object in motion stays in motion unless acted upon by an external force. In the case of Earth, this external force could be anything from a massive asteroid impact to a powerful gravitational tug from a passing celestial body. However, these events are extremely unlikely. It's also important to note that while Earth's rotation is slowing down due to tidal friction, the gravitational interaction between the Earth and the Moon, it's happening at a very slow pace. We're talking about a rate of approximately 1 second every 50,000 years. So even though the Earth's rotation is technically not constant, for all practical purposes, we can assume it to be. In conclusion, the Earth keeps spinning because of angular momentum, and it won't stop anytime soon due to the conservation of this momentum. While it's interesting to ponder what would happen if the Earth did stop spinning, it's not something we need to worry about in our lifetimes, or even in the lifetimes of many generations to come. So, while a sudden halt is unlikely, understanding the implications gives us a new appreciation for our spinning planet. So, the Earth's spin isn't just about day and night, it's a vital part of our existence. That's the truth, folks. It's quite the understatement to say that our planet's rotation is crucial. It's more than just the mechanism that brings about our daily sunrise and sunset. Let's quickly recap what we've covered so far. We've explored the fundamental phenomenon of Earth's rotation and how it's a powerful force that shapes our world in ways we often take for granted. We've journeyed into a hypothetical world turned upside down, discussing the catastrophic consequences if our planet were to stop spinning. It's a scenario straight out of a science fiction novel. Oceans migrating to the poles, massive climate shifts, and a day that lasts an entire year. Not exactly a paradise, is it? We also dived into the science behind why the Earth keeps spinning. It's all about angular momentum, a concept as fascinating as it sounds. It's the reason why spinning tops don't immediately topple over, and why planets, including ours, keep on their merry paths around the sun. The Earth's rotation is a force of nature that we're all subject to, but it's also one we benefit from greatly. It's responsible for the gentle tug of the tides and the rhythm of our seasons. It even influences our weather patterns. And let's not forget, it gives us the gift of time, dividing our existence into manageable chunks of days and nights. The power of rotation is one of the most amazing aspects of our existence. It's a testament to the intricate wonder of the universe and the delicate balance that allows life to thrive on our spinning blue marble. Our spinning Earth is a testament to the delicate balance that allows life to thrive. So next time you watch the sun rise, spare a thought for the incredible force that makes it possible. Let's not take this cosmic dance for granted. After all, it's what keeps us grounded, quite literally.